Hello, Clearview Homeschoolers. This is Nancy from the Clearview Library District, and I'm glad to have you with me today. Today, our program is about the scientific method and also about inquiry. But before we get started, let's just go over the parts in your kit so that you will know where we're going with this whole thing, okay? So first of all, you have your little guide about the scientific method. Now, right down here, it shows the information about going to the museum. The Town of Windsor has the program at the museum that goes with our program, and I think you would really enjoy that. It'd also give you a chance to use the skills that you gained today to do something at the museum. So I hope you look at that part and go to the museum on Thursday, okay? Now, on top of that, you have this paper, which is the inquiry cycle. And you have this paper, which shows you the scientific method. So we'll talk about both of those and how they're the same and how they're different and how you can use both of them. Okay. Now, also in your kit, there are a few other things in here. Skittles. Don't eat the Skittles until you're done with the whole experiment, okay? And then make sure it's okay with the adults in your house before you finish them off, okay? Oh, there's 2 cups. We'll find out about those. And finally, there is this paper that says snap a picture. Please remember to take pictures while you're doing your exploration, while you're doing the activities, while you're watching, while you're at the museum, and share those with us at Nancy at clearviewlibrary.org. You can also put them on social media and tag us, Clearview Library. We love seeing pictures of you guys. Okay? Okay, now let's see. Set all this stuff aside for a minute, and we're going to talk just a minute about the 2 methods that we have out. Now, you can follow along a little bit in here, but really it's a little better if you save this till the end after you've watched me, and then you work through it a second time, doing the experiment and everything, okay? But we're going to talk about 2 different methods of finding out about stuff, okay? And between these 2 methods, you can find out about almost anything. It gives you a framework for exploration or for inquiry. So this is the inquiry cycle. It starts really anywhere because it's a circle. And that means you can go back and forward and you can jump between places. So we're going to probably start at tuning in and then go to finding out and then sorting, going further, reflection and action. But remember, you could go back to finding out at some point in time if you needed to. You can see what else you need to do, okay? Now, this is the scientific method, and this is more often used for science experiments, and it gives us a really good framework for doing an experiment and for getting results that matter, results that are valid, okay? You ask a question, you do background research, you develop a hypothesis, test the hypothesis, analyze the results, and share your conclusions, okay? Okay, so to get started, we're going to go into the inquiry cycle a little bit more. And this seems funny, but we're going to do it by reading a book together, okay? So I want you to have this in front of you as I read, because we're going to follow that inquiry cycle. And after I read you the book, we're going to go back to the inquiry cycle and try to figure out what these mice were doing while we were doing the reading, okay? 7 Blind Mice by Ed Young. Can you see that? What is it? What is that? Ed Young, 7 Blind Mice. One day, 7 blind mice came upon a strange something in their pond. "What is it?" they cried, and they all ran home. On Monday, Red Mouse was the first to venture out. What does Red Mouse think? "It's a pillar," he said. But no one believed him. On Tuesday, Green Mouse set out. He was the second to go. What does he think it is? "It's a snake," he said. "No," said Yellow Mouse on Sunday. Oops, on Wednesday, excuse me. "It's a spear." He was the third to go. The fourth was Purple Mouse. He went on Thursday. "It is a great cliff," he said. Orange Mouse went on Friday, the fifth to go. "It's a fan," he cried. "I felt it move." The sixth to go was Blue Mouse. He went on Saturday and he said, "It's nothing but an old rope." But the others did not agree. They began to argue. A snake, a rope, a fan, a cliff, until on Sunday, White Mouse, the seventh mouse, went to the pond. And when she came upon something, she ran up one side, and she ran down the other, and she ran across the top from end to end. Can you see her right there? Yes. "Ah," said White Mouse, "now I see. The something is as sturdy as a pillar, as supple as a snake, as wide as a cliff, as sharp as a spear, as breezy as a fan, as stringy as a rope. But altogether, the something is an elephant." And then the other mice ran up one side and down the other and across the something from end to end, and they agreed, and they saw it too. The mouse moral: knowing in part may make a fine tale, but wisdom comes from seeing the whole. Now I'm going to go back one page, And I'm going to sit it right here for you guys to look at. Okay, and I want you to just think about what was going on with that inquiry cycle during our story. Now just think for a minute. Okay, now let's go back and let's look at, let's see if we can prop that right there. Okay, let's look at our inquiry cycle. Okay, that's this one. Now, what were the mice trying to find out? Yeah, they were trying to find out what that something was in the pond. Okay, so that's where they started their inquiries. Just, they had a question. What is it? Okay, now, the tuning in part is using your prior knowledge, what you already know, to make a guess about a problem or something you want to find out. And what did the mice already know to help them figure out what the something was? What did they already know? They knew what a sphere was. Or, what a cliff was. So they had prior knowledge. They knew what some things were that made them think that was what they were seeing in the pond. Okay? Now, if we go on down, we see finding out, learning experiences, finding the information. How did the mice find information? That's right. They each went and explored the object that was in the pond. So that's how they found their information. Okay? Going further is extending, doing individual or group research. So they were all doing that. But when did all that information as a group come together? Do you remember? It all came together when, let's look, I think when White Mouse went and put all of their information together. Okay? So that was the going further part. Now, did they reflect a little bit? I think that their reflection was when they said this. The mouse moral is knowing in part may make a fine tale, but wisdom comes from seeing the whole. So they reflected and they went, oh, we should have explored more before we came to a conclusion. Okay, that's the reflection part. Now, the action part doesn't really show up in our book. Usually when you learn something new and you are excited about it, you want to do more. So you might have more questions, or you might want to do something about a situation. So some examples that could happen in this book is that the mice might ask themselves, why is the elephant in our pond? Or is the elephant going to pollute our pond by stepping in it with its big column feet and making it muddy and dirty? And if that happens, what can we do about it? So those are the kinds of action that might happen in a story or in something that you're looking at, okay? So I'm going to put the book away for a second, and we're just going to go through these parts. So tuning in, we're going to look at it as how it affects you. Prior knowledge, prepare to find out more. So just tune in. You need to have a question, okay? And this could be a big question like, why are we having such an incredibly cold week right now? That's a big question. And you could do all kinds of research and find out, okay? Or it could be a little question like, why does my cat like to sleep on my stomach when I'm asleep? Okay? And you could do some research and find out about cats and their sleeping habits. Okay? So it can be a little teeny question or it can be a great big one. Okay, finding out. That's learning experiences or finding information. Now, this could happen at the library. You could come to the library to find information. Okay, you can look online. You could look at our databases. Okay, so if you're trying to solve a problem or find out more about something, those are some sources for you that you might want to use. Okay, then down here, sorting. And that's processing and sorting the information. So when you find out a lot of information, you have to kind of put it in little groups and try to figure out what's the important information. Okay, going further is extending, and you could work as a group or work as an individual and start really putting that information down and coming up with some conclusions. Okay, reflection, make connections, draw conclusions. Okay, self and peer and group and parent, teacher assessment. So that's when you really look at the whole thing. This is what I came up with to solve the problem. And is it correct? Do I need to do more research? Does my adult in my house need to look at it and see if I got everything? Okay. Did I do a good job? That's a really important reflection. And then up here, taking action. What other questions or experiences do I want to have? So sometimes when you do a really good exploration, like about the cat and why it sleeps where it does, you might find that you want to know more about cats. What do cats eat that makes them the healthiest? Or those kinds of things. So you might find you have all kinds of more questions to do. You might decide that you want to take action and maybe you want to volunteer to cat rescue because that's really important. Okay, so this is just a framework for you when you're trying to learn something or when you have a project that you want to do and it's something that works really well. Now, we're going to talk about another kind of framework for exploration too, and then at the end we're going to compare them, okay? So let's get the other one out, and that's the scientific method. Now, the scientific method works better if you have an experiment that you want to do or a process that you want to follow. It gives you a really good framework and it shows you the important parts to make sure that that experiment that you're doing has results that are good results, that are valid. Okay, so you ask a question and it says that scientists are curious. And you guys are the scientists today. So we want you to put that curiosity on and notice and observe and think about things that are happening around you. Okay? And then 2, do background research. If there's something that you're doing an experiment about and you don't know much about that subject, do a little bit of research and get some more background knowledge before you move on. Okay? Develop a hypothesis. What is a hypothesis? Do you guys know? Okay. And a hypothesis is a prediction or a guess as what is going to happen. What is the correct answer? Okay, so that's your hypothesis. This is what I think will happen. Okay, then you have to test the hypothesis. You get to do the experiment. That's the most fun of all of it. Okay, and then analyze the results. Now you have to really be careful when you're looking and doing an experiment that you're really observing everything that's happening and that you are writing down your results, that you're recording the results so that you have a really good answer. You're going to take measurements, you might take notes, you might observe, you might check how much time it takes, that kind of thing. And then at the end, you want to share your conclusion. You want to tell other people what happened. Okay? So that's another way to solve a problem, a way that works better with science experiments. Okay? Okay. Now, let's see where we're going after that. So we have read the book and we've talked about the inquiry cycle. And then we have also looked at the scientific method. Now, the experiment that we're doing today, we're going to use the scientific method more. But I want you to think about that inquiry cycle too, because it fits also. Okay? So you're going to follow your little handout here, and you're going to make sure that you are going step by step. So you are going to try to find out Whoops, I'm sorry, you can't see those cups. Let me make this go lower. You're going to try to find out if Skittles will dissolve more quickly in hot water or cold water. Okay? So, you need to have a hypothesis, which means that you are going to make a guess. Are they going to dissolve more quickly in hot water or cold water? And you are going to need to record your hypothesis, whichever one you think is going to happen. I think that they are going to dissolve better in hot water. I think Skittles are going to dissolve better in cold water. Now, you can also look at background experience and say, well, okay, a Skittle is kind of like sugar. Have I ever dissolved sugar in hot water or cold water? And when I think about that one, I think, well, have I ever dissolved sugar in hot tea or cold tea? And which one goes faster? And so will Skittles do the same thing? That's a good question, isn't it? Okay. So write down your hypothesis before you get started so that you know what your guess is and you can see if you were right or not. Okay? So one of the cups is going to get filled about halfway with very hot water. Now, don't burn yourself, but get that hot water as hot as you can. And the adult in your house can help you if you need help. I would recommend that you fill it to that very bottom line right there. Okay? The other cup you're going to fill to that very same line with very cold water. Okay? Now, when we talk about hot and cold, and we talk about filling the cups the same, filling the cups with the same amount of water is a variable. And anytime you do a science experiment, there will be a lot of variables, and you want to be as consistent as you can. So if you would fill this one up clear to the top with hot water, and this one just a little bit of cold in the bottom, you would have a pretty big variable, and your results might not be as accurate because there were different amounts of water. Okay? Now, variables aren't in your handout, but they are fun to think about because you do want your experiment to be consistent. So what do you notice about our Skittles? They're different colors. Do you think color would make a difference in whether they dissolve better in hot or cold water? I don't know. What could you do so that you don't have to worry about that variable, that your results can be consistent? What could you do? You might use yellow Skittles first. Make sure both of them are yellow because then you don't have a variable of color. Okay? So those are a couple things to just make you think about how to make your experiment as accurate as you can. Okay? So you're going to drop a Skittle into each cup of hot and cold water, and then you are going to watch them. Now, when you drop your Skittles in, drop them at exactly the same time because the amount of time that they are in the water is a variable, and you want it to be the same. Okay? Okay. You're going to watch them, and you're going to watch them and watch them until they start to dissolve. Okay? And then you're going to record your results. And in your little handout, it gives you a choice. The Skittle dissolved more quickly in the hot or the cold water. And you're going to need to circle whichever one it was. Now, do you think doing the experiment one time is enough? I don't know. What do you think? I think when you're doing scientific experiments, it's always a good idea to do it more than once. How many times do you think is good? Don't know. How many times do you want to do it? How many Skittles do you want left to eat when you're done? That's a good question too, isn't it? So you decide. There's room for you to do it 3 or 4 times, but if you want to do it more than 3 or 4 times, you can. Okay, you have plenty of Skittles. Just make sure that you dump all of the water into your sink, rinse them out, fill one hot water to the same line as cold water, and repeat your experiment, okay? Okay. Now, there is a place for you to record how many times you did the experiment, okay? So make sure you record that. And then you look at the results. Now, what if you did the experiment 4 times? And 3 of those times, it dissolved more quickly in cold water. 1 time, it dissolved more quickly in hot water. This is just a pretend result, okay? Then what would your result of your experiment be? If it was 3 times in cold and 1 time in hot, your experiment would tell you that it does dissolve more quickly in cold, okay? So if you do it more than once, you might have different results each time, but you'll have to look at the average and say 3 is more than 1. So that's the answer. And it gives you a place in your packet to record that, okay? Now, write a conclusion. By doing my experiment, I found out that Skittles dissolve more quickly in hot or cold water. And write that down, okay? Okay? So I think you'll have fun with that one. Make sure you save some Skittles to eat and ask the adult in your house before you eat them, okay? Okay. So let's just spend a minute looking at our 2 models, okay? How are they the same? You guys look at them and come up with some ideas of how they're the same? So first of all, they start with a problem, something that you want to know. Okay, so both of them start with a question or a problem. Okay, both of them you need to have some prior knowledge. Just like I talked about with the scientific method, your prior knowledge might be that you've dissolved sugar in hot or cold water. And so you know what happens with sugar. That's good prior knowledge. You need to have prior knowledge with the inquiry cycle too, something to build your knowledge on, okay? So develop a hypothesis. In scientific methods, you always have a hypothesis, what you think is going to happen, okay? Inquiry cycle, not as much, even though if you were following the inquiry cycle, you definitely could, down in here, say, well, this is what I think is going to happen, or this is what I think I'm going to find out. Okay? Testing with the scientific method, you do an experiment. With the inquiry model, you do research. Okay? You try to find out. Okay? With the scientific method, you analyze your results. You look at what you found out, you see if it makes sense, you see if it's consistent, you see if there's any variables that might have thrown it out of whack. Okay? That happens here too. You look at what happened, you say, well, did I do a good job? Did I get everything figured out? Okay? And then you have a conclusion here where you write up a statement of what happened in your experiment. And here you make connections instead. So you make connections to other things that you want to learn. You might take action, okay? So you can see that these are somewhat the same and somewhat different. And think about using these 2 methods whenever you're doing research or trying to solve a problem and see if they help you with the process, okay? So I hope you guys have lots of questions. I hope you're curious. I hope you have your scientist hats on and you're ready to do an experiment, okay? Now, at the very end of your packet, you will find this page. And this page has some books or electronic resources that you could check out at the library. And if you enjoy being a scientist, because I think we all really like being scientists, you might want to read about some famous scientists that really did research and discovered amazing things about our world. So these are either books that are available to check out, or they're items that you can check out from our electronic resource, Hoopla. And it might be an ebook or an audio book, or it might be a movie that you could watch electronically on Hoopla. So make sure you explore our catalog and see if you can find some good readings that will extend your learning on this unit. Okay? Okay. Well, I hope that you enjoyed being a scientist. I hope that you ask lots of questions and that you stay curious and want to find out wonderful things. Okay? Stay healthy, stay safe, and I'll see you next month for our next Clearview Homeschoolers Academy. Okay? As always, send me pictures. Okay? Thank you. Bye-bye, guys.